have 5 kV between the anode and cathode. You can see there's a beam of electrons shown on the back plate.
So you can see the electron deflection going on.
Like the other one, we can demonstrate the electron beam can be moved by bringing a magnet up. Different colour is purely because of the material used in the fluorescent back plate.
So I just laid the Maltese cross target over, and then you can see the shadow that remained. The flow of electrons exert a force on the paddle wheel, causes you to roll along.
This is another educational cathode ray tube, voltage for the heaters and for the anode, and as before we can move this electron beam with a magnet, but we can also apply a voltage to the plates and move it electrostatically as well. Placed a couple of coils this time around here so we can actually pass a current around these coils and create a magnetic field, and again we can bend the beam with the magnetic field generated by these coils.
Like so. And so in this here we've managed to deflect the beam downwards. The physics is exactly the same as the physics of the oscilloscope. The beam is accelerated by the anode and deflected by the plates. So I can turn that back to zero deflection. I can also produce a magnetic deflection. And the magnetic deflection now is produced by those coils, and by adjusting the current in the coils I can increase the deflection of the beam. So the way Thomson did the experiment was to start off with no deflection, put on a deflection due to the magnetic field which would bend the beam upwards, and then put on a deflection due to the electrostatic field which would bend the beam downwards.